Okay, for this video, we'll look at part 2 of Vectors 1, alright, the second lecture for Vectors 1, starting from page 9. Okay, let's go to section 2.4. Okay, here it says things about parallel vectors. Alright, two non-zero vectors u and v are parallel if and only if you can express one vector as a scalar multiple of the other. Alright, for example, if I have a vector 1, 2, 3, it's actually parallel to say 2, 4, 6. Alright, because one of them, if you multiply by a scalar multiple, alright, it's actually equals to the other. Okay, alright. Next, collinear points. Okay, 3 points, alright, if they are collinear, it will mean that they actually they lie on a straight line. Okay, and for us to prove that 3 points are collinear, all we need to do is to prove that, okay, if I express a vector with two of the points, let's say a, b, and another vector with two other points, alright, let's say b and c, then if the 3 points are collinear, the 3 points lie on the straight line, then these two vectors need to be what? Need to be parallel. Hence, all we need to show is that one can be expressed as a scalar multiple of the other. So if you are able to prove that, then it's convincing that the 3 points are collinear. Okay? So let's look at the pointers in the notes part. Okay, vector AB is equals to k times vector BC. That will imply AB and BC are parallel. And since B is a common point, okay, so ABC are collinear. So this is the phrasing that we usually do, all right? When we want to show 3 points are collinear, you prove this result, and then please mention this as well. Okay, there is a common point. Okay, because if not, I can have AB equals to, let's say, KCD. Okay, then these two vectors are parallel. AB here, okay, parallel to CD, but that doesn't mean ABCD lies on the common straight line. Okay, so unless these 2 points are the same, also you move your C to join B, alright, so C is actually B, then ABD or ACD are collinear, alright. Okay, point number 2, we may also prove that AB is parallel to AC or AC parallel to BC. In fact, there are many ways. So with these 3 points, you can form BA, CA, whatever. Alright, so just choose two different vectors, okay, formed by any two of the 3 points, and then show that one can be expressed as a scalar multiple of the other. Alright. Okay, let's look at example 3. Okay, here we are given 3 vectors, OA, OB, and OC. Alright. So can you find part 1? Can you find a unit vector parallel to vector OB? Okay, so OB, okay, I can also write in this manner, small b with a tilde below. Okay, this is the vector OB. So in order to find a unit vector parallel to it, right, we will divide this b by its own length. Also divide by its own length, that you'll get to suppose 1, 2, 3 is a vector having a length more than 1 unit, then you're actually dividing by the length of b, so to make it into just a vector of length 1. That's what unit vector means. Okay, so the way to do it, okay, divide the vector by its own length. All right, so for this case, the length of vector OB, okay, will be square root of the sum of squares of the xyz value, all right, so which is root 14. All right, so this is the unit vector. Okay, another way to see it is this way. All right, if you times the 1 over root 14 into each of the xyz coordinate, xyz component. Okay, part 2, find the values of lambda such that A, B, C are collinear. Okay, so here in the question, it is important to take note that there's actually an unknown, lambda for C. Okay, so we want to find what this value should be so that A, B, C are collinear, right? The 3 points. So to do that, we need to prove, say, AB is parallel to AC or AB parallel to BC also can. So it's really your choice. So to do that, if I want to show AB parallel to AC, I will need to show that AB can be expressed as a scalar multiple of AC. Okay, so let's look at the working. All the vector OA, OB, OC are given. All right, so here to have to express AB, we can use OB minus OA. All right, and for AC will be OC minus OA. Okay, so having formed that, then each row or each level, this should be left hand side should be equal to right hand side. The left hand side here should be equal to right hand side, and so on. So we're able to form 3 equations linking lambda and k. All right, and hence solve for them. Okay, and the way that is being used to solve here is to divide equation 1 by 2. Okay, because 3 is effectively giving us 0 equals to 0, or not very useful. All right, so we divide equation 1 with 2 so as to get rid of the k. All right, so you end up with an equation just involving lambda, and you can solve for the lambda value. All right, so these are the 2 possible lambda values, and that's the answer. Okay, if you need to take down the solution, please pause the video. All right, let's continue with the next section. Okay, next example, example 4. Here we are given the position vectors of points A, B, and C. All right, meaning this is vector OA, sorry, the OB, OA, and then the next one OB and OC. All right, can you find a 4th point D such that OD, the position vector of D, sorry, we want to find the position vector of D. We want to find this so that this 4th point D, right, together with the earlier 3 points A, B, C, actually forms a parallelogram, and it must be in this order, A, B, C, D. Right, so what you do is to draw a parallelogram diagram, all right, for your working, easier to see. It's also okay to, let's say, label A, B, C, D as well. Just that it really needs to be in this order, all right? A, B, C, D, or either clockwise or anti-clockwise, it won't skew the analysis, all right? So also at the same time, let OD, vector OD be XYZ. Okay, so to find it, if the 4 points form a parallelogram, what's very important is that then this vector AD must be exactly the same as BC because they point in the same direction and they have the same length. Okay, or alternatively, you can use the fact that vector DC is equals to vector AB exactly. Okay, so here, what has been used is to show this. We want to use the fact that AB, okay, is equals to DC. All right. So to do that, let's find expression for each first, AB and also DC. With what's given in the question, okay, AB can be formed by OB minus OA, okay, hence getting this vector. DC, okay, will be OC minus OD, and OD will have let it to be XYZ, okay, the vector XYZ. And that's what we want to solve, right? So now, given the fact that ABCD forms a parallelogram, so this must be true. Vector AB must be equals to vector DC. Hence, these 2 vectors are exactly equals to each other. All right, with that, we can solve for XYZ. All right. So from the first row, okay, we get X equals to 1, second row Y equals to 13, and so on. Okay, hence getting the answer. All right. So what's important here is wherever you are told 4 points form a parallelogram. All right, so draw a diagram first, okay, for the points mentioned, and then use either opposite sides, all right, to compare with each other. The two vectors pointing the same direction should be exactly the same. Okay. Example 5, all right. Okay, here we are told that suppose a cannonball is fired, all right, from a cannonball is fired from a cannon and cannon is placed at the origin. How could we model its trajectory given certain information about initial configuration or initial velocity, right? Suppose initially the velocity is 5 meters per second, okay, and also the trajectory of fire is at an inclination of 30 degrees. Also, this 30 degrees, all right. And the ball will move under the force of gravity as well, okay, but will maintain a horizontal velocity, okay, if the air resistance is ignored. So with this, right, we can split this vector here, okay, 5 meters per second into two components, horizontal component and the vertical component, all right. Okay, with the horizontal one staying constant, but the vertical one affected by gravity. So let's look at the diagram. Or if this is 30 degrees, okay, and this is kind of like 5 units, then we know this vertical component will be 5 sine theta. All right, and then here, this will be 5 cosine theta, and theta is 30 degrees. Right? So this will be how the initial velocity, right, is resolved into the horizontal and vertical component. Okay, so now if we want to look at what's the velocity of the ball, we can say that okay, and let kind of a vector representing the horizontal component and the vertical component. Of course, the vertical component would need to also subtract tan t, all right, which is the velocity caused by the deceleration, all right, gravity's deceleration, okay. We know the acceleration is kind of negative 10, so velocity wise, and because velocity, what happened? Okay. All right, and because acceleration is dv dt, so to get v, we would integrate, okay, and hence getting negative 10t here, all right. Okay, for the velocity resulted from the gravity, all right. So overall wise, the vertical velocity, all right, will be this amount. Okay, so that's how vectors can come into play, all right, to represent the result into these two components. Okay, can I leave you to look through the rest? All right. Okay, let's move on to the last section, 2.6, on ratio theorem. Okay, what this theorem is about is this, let vectors OA, OB, and OP, all right, be the position vectors of these 3 points A, B, P. Okay, if P divides the line segment AB in the ratio m is to n, okay, then the position vector, okay, hold on for a while. Okay, then the position vector OP, okay, can be found by n times of okay, sorry, one more time. The position vector OP can be found by n times of vector A, n times A, plus m times of vector OB, all right, then over total proportion like that, m plus n. Okay. Okay. What makes us say that? Okay. Is we can actually try to show it. All right. Vector OP. Okay. Suppose I see finding vector OP in this manner. I first start from O. Okay. Move to B. All right. OB plus BP. Is it okay? OB plus BP. BP is a proportion of BA, or it's actually n over m plus n of vector BA. Okay, and BA is what? Vector BA, okay, can be expressed as OA minus OB. Okay, so in this way, actually, we can get the ratio theorem result. Also, B will be 1 minus n over m plus n vector OB, and this gives m over m plus n vector OB. All right, so it's the same. Okay, so I hope that convinced you. You can also show this result by going this route, OA plus AP instead, all right, to represent OP. Okay, so that's ratio theorem, right? So now that we've understood the ratio theorem, so let's revisit it again one more time to know how to use it. So next time, if you want to find the position vector of a point, okay, on the line segment, say AB, where A and B are known, then actually you can do this. If you know the ratio AP is to PB is m is to n, then just use n times of vector OB plus n times of vector OA over total proportion m plus n. Okay, and if the P happens to be the midpoint of AB, then the ratio will be 1:1, isn't it? Also, this will become 2, and then here 1:1. Right? So OP is just half of OA plus OB. Okay, so let's see, let's apply this ratio theorem, all right, to answer example 6. Suppose there are 2 points with these 2 position vectors. Can you find the position vector of P which divides AB in the ratio 5:1? So it'd be good to draw a diagram like that. Or P actually divides the line AB in a ratio of 5:1, right? So depending where your origin is, let's say here, then we form this diagram. So now to find OP, okay, we can use the ratio theorem. 5 times of OB plus 1 times of OA over total proportion 5 plus 1, which is 6, all right? Hence, giving us this answer. Okay, how about the next one? Similarly, if I want to find Q, a point on line BA which divides it in the ratio 2:3, all right, divides BA in the ratio 2:3, all right, so this should be 2 and 3. Okay, so to find OQ, okay, it will be 2 times of OA plus 3 times of OB over total proportion, all right, 2 plus 3, which is 5. All right, so we can solve it, all right, and get this answer here. Okay, let's move on to the last example. Okay, example 7. Okay, which involves this context, all right. Relative to origin O, 2 points A and B have position vectors OA, OB respectively, and also the fact that OA and OB are non-parallel vectors. Okay, the points C and D lie on the midpoints of OA and AB respectively. Okay, so if I were to get this information into a diagram, so point C, all right, lies on OA in the middle, is the midpoint of AB, and point D is the midpoint of AB. All right. Then what else? The line segment OD and BC intersect at point P. Right? Such that the ratio of OP is to PD is 1, lambda is 2, 1 minus lambda. Okay, with this, first, can we find OP in terms of lambda, A and B? Okay, so at this point, maybe perhaps this information hasn't come in yet of the mill. You can ignore it first. Okay, it's actually meant for later part. Okay, how do we find OP? Okay, there are many ways. One way is to see that using midpoint theorem, or because D is what? That means we find OD first. Okay, and then because OP, okay, sorry, the diagram is getting a bit complicated. Okay, let me clear it a bit. Okay, so to find OP, we first find OD, right? OD. And D, since it's the midpoint of AB, okay, using midpoint theorem, it will just be OA plus OB over 2. Okay, all right. And now that OP is found, okay, now that OP is found, OP actually will be lambda over lambda plus 1 minus lambda of OD, isn't it? Oh, this is OP. So, but the denominator is simplified very nicely to a 1. Also, it's just, this part is just 1, so it's just lambda OD. And so actually that's the usefulness of letting ratio be in such of lambda with 1 minus lambda. Then when you add them up, it gives a nice 1. Okay, so that's one strategy or technique we can use. Okay, but which the question guided us in this case. Or but in other cases, you may want to think about using such ratio. Okay. Alright, so we have expressed OP in terms of lambda A and B, answering the first part. Now, second part, can you show then that the ratio of BP is to PC is 2:1? Alright. Let me clear this. Alright. So next part is this. Okay, we want to show that BP BP is to PC, is 2:1. So what the solution does firstly, right? One of the possible method is to let what we want to solve, okay, BP is to PC, this ratio be lambda is to 1, mu is to 1 minus mu. So it's really using this earlier technique that we mentioned. If you add them up, it gives a nice 1. All right. So the expression won't get too complicated. Okay, so instead of letting it be, let's say a ratio, say m is to n, then there are two things to solve as well. Okay, it's not advisable. Okay, let me erase this. Alright, so firstly, okay, that these two parts of having this ratio, which is what we want to solve. Alright, then next, okay, I'm going to express OP in terms of AB and unknown mu, instead of earlier on AB and unknown lambda. Alright, so what I would use is to find OP. Okay, let's have uh, 1 minus mu, okay, over total 1 minus mu plus mu, okay, which is alright. Okay, what's happening to the right things? Okay, give me a while. Alright. Okay, so what we have done here is to find another expression for vectors OP, okay, in terms of mu. Earlier on, we have one expression in terms of lambda. So since both of them are talking about vector OP, they must be equal to each other. Alright, so that's what I will use next on to solve for mu. Alright, so equating the two, okay, comparing OP, OP is both this expression and this one. So you equate that. And what next is very important technique, alright? That for each side, right, actually involves vectors A and B. So the coefficient for A must be equal to the coefficient of A on the other side. Also, these two must be equal to each other. And also the coefficient of B equals to this one, 1 minus mu. Okay, so then we are able to form two equations linking lambda and mu and to solve for that. Right? Okay, here please take note that we can only do such comparison of coefficients if the two vectors are not parallel to each other. Okay, if not, right, there will be many possibilities, infinitely many possibilities. Okay, and we can't just equate in that manner. Right, so having formed these two equations, you solve them, alright, you can get mu's value, but we don't need to get all the way down to solving for mu, because what I'm interested in is the ratio mu over 1 minus mu, isn't it? That's the ratio of side BP is to PC. So that's why the solution doesn't solve mu completely, but just dividing this down, alright, and then multiply the 2 over, okay, to get the ratio 2:1. Okay, so that's the answer. Alright, so that's one method. Okay. Okay, before I look at method 2, maybe let me mention something. Here the question is quite good in guiding us to do part 1 first to get an expression in terms of lambda, alright, and then later to show this ratio. Okay, it can be a question from the start, right, that just jumps to part 2, isn't it? Or let's say I tell you C is the midpoint of OA, D is the midpoint of AB, and then you join two lines, and then what I want is, let's say this ratio is to this one. So then we have to think of, letting maybe OD also split into lambda is to 1 minus lambda, and then get two expressions for OP, and then compare using the method that we've just seen to solve for lambda and mu. Okay, so that will be then a harder question or with less guidance. Okay, and such problem, right, actually involve this thing called the median. Okay, median of triangles. Okay, median of a triangle is a line joining one of the vertex to the midpoint of the other side. Yeah, so this line here is the median. Same thing, if I join the other vertex O to the midpoint of the other side D, this red line is also a median. Alright, and it is quite interesting to note that where two medians intersect this point P, actually the ratio will always be 2:1. So here also 2:1. And if you join the third median, this ratio is also 2:1. Alright, so for your info on that. Okay, let's look at method 2 now. Okay, to solve for the ratio 2:1, okay, we can also use the this idea. Let BP, okay, be a proportion of BC, because they are parallel, right? Then BP is OP minus OB, right? And BC, OC minus OB. So you can get expression for KBC, all right? And this is vector B. OP also expressed in terms of A and B, which is done in part 1. And you can rearrange to, two vectors, one on each side of the equation, and also do this comparison. The coefficient of A must be equals to that on the other side of the equation. And the coefficient of vector OB is equals to this negative K. Alright, so also forming two simultaneous equations to solve for K and lambda. Alright, so then you can get the same conclusion. If K is 2, what is K to begin with? K is the ratio BP is to BC. So if the ratio is 2:3, then this must be 2:1, right? So we'll get the same answer. Okay, so therefore answer will be 2:1, right? I think the solution doesn't answer all the way to the what's required. Okay, Ken. So that's for this second lecture, all right, of your vectors part 1. Okay, so please go on to look at the checklist and see if you have understood all the important skills and concepts that is needed for this section. All right, that's all for this lecture. Thank you very much.